All right, so we're going to do this in 2 parts, 2 days. Today we're going to talk about adding and subtracting numbers that are in scientific notation. Okay? So let's start with the rules. To add or subtract, it's going to be super important that you always look at the operation you're doing. Are you adding? Are you subtracting? And then eventually, are you multiplying or are you dividing? Because that obviously affects the answer. So for adding and subtracting, which is what we're going to talk about today, here are the steps. Step 1, check the power of 10. So whatever you're doing, the number times 10 to the whatever. In order to add or subtract, you have to have the exponents in the same power of 10. So you move the decimal as needed to adjust that power of 10. And we'll practice with this. But before you can add or subtract anything, they have to be in the same power of 10. It's basically like having like terms, right? So if you have, 2x plus 3x to the 7th, you can't add those because they're not like terms. Their exponents are not the same. It's the same with scientific notation. We've got to have the exponents be the same before we can add or subtract. Then, to follow with that, if the powers of 10 don't have the same exponents, make sure you move the decimal, change the exponent, so that the exponents of each value, each power of 10, are the same. Once those exponents are the same, we add or subtract the factors, which are those first numbers that come before your times 10. So you just do the math. You only add or subtract the factors. You do not mess with the exponent, the powers of 10. You just add or subtract the factors. And you keep that same power of 10, whatever you had started with. And then you do times 10 to the whatever. Leave it like that, right? Because we're going to leave our answers in that scientific notation. But always double check that your answer is in scientific notation before you say that's my final answer. So double check that the factor is 1 or greater, but less than 10, right? It can't be 10. Times 10 to a power. So it involves a bit of decimal work, which we'll practice, but you got to always be paying attention to that. Okay? Here's example 1. We've got 2 numbers in scientific notation, 4.6 times 10 to the 3rd plus 8.72 times 10 to the 3rd. 2 things we always want to look for before we start is, first of all, what's our operation? In this case, we are adding, which means we need to make sure that our exponents, our 10 to the power of, have the same power. In this case, they do. So we don't have to do any work on the front end here. We just now need to add the factors. 4.6 plus 8.72. 4.6 plus 8.72. And we end up with 2, 13, 13. Is that right?
Yeah, it is.
Okay. So we add our factors and we keep the power of 10 that we started with, that was the same. And then our last step is to check, is this answer in scientific notation? No, it's not, because this is too big. This is not between 1 and 10. So in order to get it to scientific notation, we need to move the decimal 1 place to the right. And in this case, we would add 1 to our exponent, right? Because we went from a bigger number to a smaller number. So in order to get back to that 13.32, we'd have to add an exponent. So our answer in scientific notation is then 1.332 times 10 to the 4th power.
So if the power of 10 is the same number on both sides, you just add 1.
You just start by adding.
That's the final answer?
That's the final answer. It is in scientific notation.
So
Yes.
just add 1 to make
Because
But this is not on this
13.
Correct.
It has
To make, yeah,
the... If it was already 1.337...
then we were done.
Which means you add 1.
Then we were done. We'll do more. Bear with me. We'll do more. All right, let's do some more. We're going to do quite a few to practice, you guys, so don't worry. Okay, let's do this one. 3.5 times 10 to the negative second minus 6.6 times 10 to the negative third. A couple of things we're looking for. First, our operation, we're subtracting, which means we need to have our exponents in our powers of 10 be the same. Are they the same? No. Okay, so we're going to have to move the decimal in one of these to make it the same power. Okay? Remember last time we moved our decimal to the left and we added 1. If we do that on this 6.6 times 10 to the negative third, we move our decimal to the left, it becomes 0.66. And if we add 1 to that negative, or 10 to the negative third, it becomes 10 to the negative second.
Ooh, so you did the same.
Right. So now we've got our exponents the same, right? Now we can subtract the factors. So we can do 3.5 minus, line up your decimal points, 0.66, right? And I'm assuming everyone will probably be using a calculator. So 2.84, bring down your same 10 to the power that you started with, 10 to the negative second. Is this in scientific notation?
Yes.
Yes, our factor is bigger than 1, less than 10. So we can just leave this. When we did the subtraction, we still got a factor that was within our range for scientific notation. So we don't have to do anything on this one.
Even if the exponent is negative?
Yes. So for scientific notation, we can leave our exponents negative. It is okay. Okay? All right. Let's do another one. Okay. 8.2 times 10 squared plus 3.41 times 10 to the negative 1. We are adding, which means we need to get our exponents the same.
And if it's multiplication, do they have to be the same?
We'll talk about that tomorrow. Okay? Addition and subtraction, they have to be the same. To answer your question, no. But just for addition and subtraction. Right. All right, so let's change one of these. It doesn't matter which one you change. But we need to have them both with powers of 10 to the same exponent. Which one would you like to change?
-1.
Okay. If we move this, we need to add how many to negative 1 to get it to equal 2, right? Plus 3. Okay? Which way, if we go back, in order to add 1, which way did we have to move our decimal point? To the left, meaning we need to move our decimal point how many to the left?
3.
1, 2, 3.
You have to move it 3 times.
3 times to the left. So we end up with 8.2 times 10 squared. That one's staying the same. Plus, we moved our decimal 3 to the left. 1, 2, 3, 4, 1 times. And then we get 10 squared. Now we've got our exponents the same, so we can just do our addition of our factors. 8.2 plus 0.00341. 8.2 plus 8.2 2, 0, 3, 4, 1 times what? 10 to the second, because that's what we had when we started. Is this in scientific notation?
Yep.
Yes, because it's 8 point whatever. So we don't have to do any more movement. We just had to do it at the beginning. We don't have to do any more now. Okay. Let's do another one. Oh, thank goodness. Okay.
Oh, yay.
Yay. Okay, we're subtracting, which means our 10 to the powers have to be the same, and they are. So do we have to do any work on the front end moving decimals? No. We can just do our subtraction. Oops, 7.8 minus 4.5.
3.3.
Yep. 3.3 times what? Is this in scientific notation? Yes. So that is pretty easy. Let's do another one. Oh, sorry. Okay, not done. Sorry. Okay, look at this one. Notice how the first number is not given in scientific notation. We can either write it in scientific notation. We have to, because these aren't in the same form, right? What is 2 in scientific notation? 10 to what power?
10 to negative 4.
0.
Right. What is 10 to the 0 power?
1.
1. Is 2 times 1 2? Yeah. Because this 10 to the 0 really means 1.
Oh my god.
Oh my gosh.
All right. Now,
Oh, so then you have to get it to the 4.
correct. Now we need to get our exponents to be the same so that we can correctly add.
We could move 2's decimal to
I like getting 0 up to 4.
Let's get 0 to 0.
So which one do we want to move?
The 2.
The 2? Okay. We would need to add 4, right? And which means we'd need to move our decimal which way? Left. If you're going to add a number to your exponent, you move the decimal to the left. 2, 3, 4. 0, 0, 0, 2. So then we get 0.0002 times 10 to the 4th plus 1.75 times 10 to the 4th. Yes, Zegan?
That doesn't make sense because then it would be a negative 4. If
I
you move
agree
it
with
to the
you.
left.
But you're going, no, because you're going from a big number to a smaller number, right? No, that's if you're going from a bigger number to a smaller number. Well, if you're, no, sorry. This gets so confusing, so I confuse myself also. If you have, start with your 2, right? Let's say we have 2 times 10 to the 4th. If you started with this. Is that number in standard form going to be really big?
Yes.
Yes, because you would move your decimal 1, 2, 3, 4, right? And it's going to be like 2, whatever, 20,000. Okay? But let's go back. Okay, 2. What if we change this 2 to call it this? Oh gosh, this isn't working. Zegan. What? Let's finish this one. Okay, now we've got our exponents the same, so we can do the addition. 0.0002 plus 1.75, which gives us 1.7502 times 10 to the 4th. Is this in scientific notation? Yes. Bigger than 1, less than 10. Okay, you will see a couple like this where you're given 2 or like a whole number. To write in scientific notation, put it times 10 to the 0. Okay, last one. Try this one on your own. we want to subtract 2 to our exponent. When we were adding 2, we moved to the left. If we're subtracting 2, which way should we move our decimal on our 5?
Right.
To the right. Yeah.
Now I'm stuck at the end.
Okay, so we get 500 times 10 to the negative second. 4.3 times 10 to the negative second. Did we get here?
How did we get 500?
Because we need to subtract 2 from our exponent. Right? When we were adding 2 to the exponent, we moved the decimal to the left. Remember that?
Oh yeah.
And so now we're subtracting 2, so we're going to move the decimal the other way, to the right, 2 places. Okay, now we can add 4.3 plus 500. That's not lined up, but we get 504.3 times 10 to the negative second. Are you with me to there?
Yeah.
Is this in scientific notation? No. So we need to move our decimal 2 places to the right, right? So that's 5.043.
Left.
Sorry, to the left. Thank
Would that
you.
make it more negative? So now it's -4.
Oh, it's plusing.
What do we, yep. When we moved our decimal to the left, what did we do to our exponent?
Made it smaller. Bigger.
We added,
Oh. I don't get it.
right? Yeah. When we move the decimal to the left, we add that number of places to our exponent.
So it's 0 or -4.
So what is it? Times
Time to the
10 to the 0, which is just 1. So you could give it like this, or you could just say 5.043.